Welcome to day 2. I hope you all had a lovely evening last night and are rested and ready. Just a couple of quick general things. There is a water refill station next to the toilets at L5. The coffee break will be at 10:30, and then the next session starts at 11. If you hear a fire alarm, it's real. So that's the general stuff, and welcome to today's session on measurement reporting and verification. I'm Professor House, Joe House, please just call me Joe, from University of Bristol. I started really in bioenergy and climate cycle stuff, carbon cycle, but ended up being sucked into the dark world of MRV, which I now really love, all the bean counting, and it's really quite political, actually. It's not as boring as accounting sounds, and done a lot of IPCC work. So I'm very pleased to be here and listen to the session today. We have two speakers, and then we have a very exciting launch for you, a launch of a competition. So I am going to hand over first to Paul, who has been a consultant for 25 years in 35 countries on climate policy, and he's worked for 10 years in CCS and carbon storage and regulatory frameworks. And his favourite pasta is alfalfa, I believe. Did I say that right? Alfalaf. Something. Anyway, one I've not heard of, so I'm going to try it. So handing over to Paul.
Yeah, thanks, Joe, for the introduction. So Alfalaf, for those German speakers in the audience, my wife is German. She makes a good pasta Alfalaf. So, yeah, that's my favorite. Yeah. Just for clarification. Or noodle Alfalaf. So this morning I'm going to talk about MRV for CDR. I'm going to not talk much about the V, because that's kind of like administrative stuff, but I'm going to certainly try and talk about the M, and a lot bit about the R, but the R in the context of more of accounting. So how do we account for all these things across different reporting entities? Yeah, and it's an absolute privilege just to mention also some of the people that have helped me to be part of this. Firstly, Steve and the organisers at CO2RE for their kind invitation to make this presentation. Also to the IEA Greenhouse Gas Programme, who have been sponsoring a study on this topic, which is a little bit behind schedule, but it's been quite an intensive journey of a very complicated subject, and one of those subjects that actually attracts quite a lot of attention in the CDR space. So first point is, what is MRV? Usually we talk about an acronym soup. Here we have an adverb soup of what MRV is all about. So we have reliably, transparently, comprehensively, accurately, consistently monitor, report, measure, and verify GHG emissions and removals at different scales and different entities, organizational, program level, project level, product level, or value chain level. So MRV has lots of different ways of being looked at and being sliced up across the piece. But it is critical to understanding and tracking the effectiveness of different actions to mitigate climate change, and also to value those services or to penalise them in the case of emissions and under a carbon tax or so. And that's just something that's our own definition. There's a bit of a mash-up from lots and lots of different working definitions of MRV. Mostly, we've been talking about MRV in the CDR space around these areas. So the independent crediting programs, and a bit less so around Article 6.4 under the UNFCCC. But that's where most of our discourse has been to date. It's all about getting projects and MRVing them and giving credits to them. I think what's received less attention, but is also equally important, is the national GHG inventory systems. And good to see Steve touch on it yesterday morning in the plenary discussion, because I think it has been a sort of neglected topic in our discourses so far. And hopefully, if there's one thing that I'm going to be able to do this morning and convince you all, is that the linkage between these two systems is really, really important. So if you go away with understanding why it's important, then I feel like I've done my job. So I'm going to try and walk through those two topics a bit to get everybody a little bit level set on where we're at, and then try and explain why I think they're really important. Firstly, I think this is what I understand for a project-based crediting system. how we MRV projects. We basically have a baseline, and then we have measured removals, and then we have those emissions that are associated with delivering that removal effect, and then the difference between the baseline and the net of those calculations is our net removal effect, and that's what we can credit. Now, that's a simplified view of it. It's a bit more complicated than that, so we've got a number of different elements that overlay what we're trying to do. Firstly, when we talk about removals, well, anything between a baseline that's positive and 0 is going to be an emission reduction or an avoided emission, so it's not a removal. Secondly, we have to deal with additionality, so we have to try and understand, is our baseline the right baseline or not? And while most people think additionality is something that we can just put into a mixer and come out the other end with an answer, it's far more complicated, and it's extremely subjective in many cases. We then have a problem, what I call adverse selection, or what a lot of people call adverse selection. So if we have a baseline and we fix that, are we just simply creating a selection bias problem around the baseline, which allows us to generate credits for activities which aren't actually additional? And the third part is really, how do we deal with reversal risk? If we store carbon, does it stay down there or does it come back up? So that's just a sort of graphical trying to express all those challenges we see in a project-based mechanism in the accounting frameworks. Of course, what we have is a bunch of guiding principles that tell us how we're going to not do all these things wrong. So usually the reductions or removals need to be real, need to be measurable, need to be additional, not double counted, no leakage, and permanent. And of course, this is what all the standard operators or registries or programs are operating around, and we then have overarching frameworks like the ICVCM and its core carbon principles, which are trying to sort of govern the voluntary marketplace, and then you have the sort of more regulated systems as well. If we look at where we're at today, just to mention, before anyone tells me, of course the baseline doesn't have to be above 0, it can also be below 0, depending on where your start point is, but the same challenges still apply. Where we are today, in the coverage of MRB at project level, we have something like, and it's quite hard to count these, but there's probably more than 50 methodologies out there under different schemes that are crediting nature-based removals today. So talking about forestation, forest management, soil organic carbon improvement or enhancement, agroforestry, peatlands, and that gamut. So that's spread over a wide range of different standards, not just the ones I mentioned earlier, but also a number of national programs. Like in France, they have a national program. Austria has a system. Germany has a different systems. A lot of diversification in that sort of certification space on the nature-based side. In the novel side, or novel CDR space, it's a little bit smaller, but it's growing rapidly. It's about 20. Difficult to count because what we did here was try to separate them a little bit by the CDR method type, but some of them overlap. So some of these methods for DAX and BEX are the same. So we've got a little bit of double counting going on there, for want of a better way of putting it. But what you can see here, this kind of spread is getting wider and wider. We've now got Isometric has just published this ocean alkalinity enhancement last month. I think it's the first of its kind. We've got 2 on biomass burial, which are sort of very new and kind of novel and interesting. Bio oil storage, enhanced weathering is sort of, again, not something that was there until very recently. But the key thing is this has happened over a very short space of time. A lot of new ideas coming into how we can do these things. What's less clear is how many projects are actually using these methodologies. The methodologies are there, but whether they're actually being applied and developing credits, we haven't looked at. But if anyone has a view on that, would be very welcome to make an intervention after my presentation. On the national MRV side, so this is the National Greenhouse Gas Inventory, we have a bit of a longer history. This goes way back to the early 90s. Even I was at school then. So, yeah. Really where MRV in an international context comes from is these 2 key articles in the UN Framework Convention itself, which was agreed in 92, came into force in 1995. Article 4 and Article 12 mandate all parties to the convention to periodically publish, update, and report inventories of anthropogenic emissions and removals by sinks using comparable methodologies. So that's a key thing to keep in mind there as well. And then building off of that, we've had a few sort of steps along the way. We had the Kyoto Protocol come in 1997, which really upped how we look at inventories, because suddenly we had countries with quantified targets who needed to be able to inventorize and have certainty over the numbers. So that comparable piece became really important back then. And some of these amazing documents, if you haven't read them and you're into this stuff, then please read the Marrakesh Accords, because this was an agreement made in 2001 between lots and lots of clever people who are no longer working in this space. And it's really amazing that they were able to come to this international agreement with an accounting framework, with agreed principles and methodologies. Then we had things like CDM, afforestation, and reforestation modalities and procedures. This took a bit longer, which kind of exemplifies the sort of challenging and contentious nature of forestry credits. Then we had the Bali Roadmap in about 2007-8, which really set up where we are today with the Paris Agreement. But part of that was to actually bring developing countries on board with more enhanced reporting and inventory compilation requirements. And then in 2011, we had CDM, CCS modalities and procedures. So how are we going to give credits to carbon capture and storage projects, focused mainly on fossil CO2, not DAC or biogenic like we are today. And now, today we have the Paris Agreement, agreed 2015, entry into operation 2020, and a key element in there is the Enhanced Transparency Framework, which is telling us how countries need to report and comply with their NDCs, track their actions. We also have Article 6 RMPs, Rules, Modalities and Procedures. They changed the acronym, but it's basically pretty similar to what we had under CDM. And then, in terms of the methodologies, those common methodologies that countries have to follow, we had 1996 revised guidelines from the 1995 version. Then we had the 2006 update, which is pretty much the standard today. And then just a few years ago, actually it's 5 years ago now, we had the 2019 refinement. But the interesting thing, and I was just discussing this yesterday with Joe, is that the 2006 guidelines only from this year will actually be mandatorily applied by parties. So it gives you a sense of the time frame needed. We're talking nearly 20 years before they were published to actually being used by parties, because of the biennial. This year, all parties to the Paris Agreement will publish their first biennial transparency reports, and they have to follow 2006 guidelines in that. Well, mainly. There's some exceptions, but I won't go into those. And then surrounding all those is a bunch of other stuff from IPCC, wetlands guidance, the good practice guides on LULUCF, whole raft of methodological standards that have guided how we're going to monitor and report emissions and removals by countries. And then I haven't mentioned a couple of other things. There's things like the Greenhouse Gas Protocol, which has been running in parallel, looking more at corporate and non-state actors' inventory methods. And of course, they try to follow the same methods and programs. But also in Europe, we had a lot of MRV development, which was kind of really quite groundbreaking, some of it, particularly around the EU ETS and the whole reporting programs there. So all of these things have been around for a while. So the point is MRV is not new, even though we're just fixated on where we are with MRV for CDR in the last 3 years. We also need to draw a little bit more on this body of work. And then finally, just to mention that the CDR expert meeting will take place from IPCC next month, and that's going to pave the way for a 2 or 3 year program to try and look at how CDR can be better integrated. And if we go to the next slide, I'll come back to that in a minute, but just what they're trying to do, if we think about where we're going with net zero, the net zero conceptually is the point where those measured emissions and measured removals in the inventories are in an equilibrium or 1-to-1 sort of ratio. They're compiled by IPCC methods. They have a different set of principles, what we call the TAC principles, transparency, accuracy, completeness, consistency, and comparability. So, in fact, accuracy is probably less important than comparability, because we want to be able to see if things are improving over time, even if there's systematic errors. As long as we can see if things are going in one direction or another, I think comparability is actually probably more important, and compatibility, so we can compare consistently over time and over space. And the way we're doing that today, as I mentioned, is the Enhanced Transparency Framework, which is embedded in Article 13 of the Paris Agreement. Where are we with MRV and national MRV and CDR today? Well, as you can see from this, I tried to quickly characterize with the same sets of CDR methods on the left what the coverage is within those IPCC guidelines today. And okay, there's a whole volume dedicated to AFLU, agriculture, forestry, and other land use, in volume 4. BECCS is covered in the various parts of volume 2 and volume 3. But after that, it's a pretty thin sort of spread of stuff. So, I mean, DAX is kind of covered because the geological CO2 transport and storage is covered. So if we assume that those same rules can be applied to direct air capture CO2, then we can say it's partially covered. But after that, there's not a lot going on for weathering, for bio-oil storage, for biomass burial, biomass sinking, and all those things. So that's not to say that that's a problem, because these are guidelines. And guidelines, they're not standards or rules, they're guidelines. So, and if we actually look at what the Paris Agreement says on this, it says parties can choose their own methods. So you can basically do what you like as a party, as long as it clears the V part of this MRV, and that's the international expert review of the inventories of parties. So it's not all lost, but there are some gaps and challenges. And I guess once you have parties doing their own thing, you have a problem with that consistency, because you're only going to find parties doing things differently and measuring things differently, and that can create problems for environmental integrity across the piece. So as I mentioned at the start, what I want to convince you of is that we need to have these two things working in tandem. So I'm going to try and do this visually. You're kind of my guinea pigs on this a little bit, because I haven't done this slide before, but bear with, and we'll see how it goes. They are separate MRV systems, but there are also linkages, and I've tried to sort of show this connections and the connectivity between what you measure at the project level and how we capture that at a national level. So, and the idea of putting these squiggly lines in, and the variable squiggliness on that, is to show that there's a signal there, but it's quite a noisy signal in some cases, and how do we close that signal to noise gap? You may say, well, why do we care? Firstly, we care because there's an environmental integrity challenge baked into all of that. And that environmental integrity challenge becomes real when we think about what is called corresponding adjustments. So parties are going to have to, if they credit stuff at the project level and sell it to other countries, they're going to have to add it back on to inventory. If they haven't measured it properly in the first place, they're going to have a disconnect. But I tried to characterize this as two challenges. Firstly is an allocation challenge. So that's the how. How is the project stuff being recorded in the inventory? And then the second challenge is a visibility challenge. So how much or whether it's even being recorded at all. So I'm going to try and dig very quickly into those two challenges. So firstly, if we think about the how, well, as I showed earlier, we've got a wedge of avoided emissions. Avoided emissions are never recorded in an inventory. So if we're giving credits for them, they're not going to fit to the inventory of the party. So that's one problem. Then we've got things like activity emissions and leakage emissions. Well, they're happening in the red wedge there, the actual emissions. And then we've got like problems of imported embedded emissions. So if you're importing chemicals or so on and so forth, they'll be recorded in someone else's inventory, but not in your inventory. So you may be getting more credit. This is why we always say, well, we need to look at the life cycle impacts at a project level. Again, that's going to create a disconnect between what you're measuring at a project level and what you're recording at the inventory level. Second challenge is the visibility problem. So this signal on what we measure as removals is quite noisy. Hence, I made that more squiggly. And so what you can end up with is having a systematic overestimate. So if you're doing some of your inventory, which is kind of systematically overestimating the amount of removals you're doing, and you go in and then try to do observations on the ground and find out, well, hey, those assumptions are wrong. We're actually getting far less removals, then we're going to overestimate what's in the inventory on one side. But of course, the reciprocal also applies. We might just have this visibility problem. We might not be measuring anything at the national level, but we're measuring at the project level. And you say, oh, well, so what? But I think the key thing is that, firstly, if you're creating projects with credits, you're essentially creating what I would call a hot air problem. It's not hot air in the Kyoto sense of the word, but the point is that you're creating credits that are being counted against emissions. Those emissions are being measured. They're real emissions, and you're generating credits and offsetting those. Those removal credits aren't actually anywhere in the inventory. The reciprocal of that, again, there's always a flip side, is that for countries who want to create a domestic program, they want to create a domestic project-based crediting program, like the EU's doing under its carbon removal certification framework. Well, there's a risk of policy failure, because what the EU measures is the inventory. It doesn't measure the projects. So if you implement a policy that says, well, I want more projects, I need to make sure those projects are giving me something as a policy maker. And if those connections aren't in line, then the policy is not doing its job. So hopefully that's a convincing story of why integrity matters in markets and why we need this lining up of MRV between projects and national inventories. And I'll leave it there just to say a lot of this information is in a forthcoming report. Hopefully we're going to finish that off in the next coming weeks and be in public domain. So I'll leave it there. Thank you very much for listening.
Thank you, Paul, for articulating so well what I spend a lot of time trying to explain as well, so that was brilliant. Just to say, we're going to combine questions afterwards, so when you're putting your questions in the chat, please say who the questions are for. That would be really helpful. And next we've got David Yeo, who's a professor at the University of Hawaiʻi at Mānoa and co-founder and chief scientific officer of Seaworthy.
For the internet. Okay, so thank you for the organizers for having me. And some of you might follow me on social media and you might expect this talk to be funny, and it's not funny at all. I cut this down from about 40 slides to 20, so all the funny bits are in there. So I'm going to talk about the ocean today, and I just want to say something quickly about Seaworthy. We are a nonprofit research organization that's focused on building open source tools to do MRV for the ocean. And we're funded by philanthropy and government funders, and there are right now 12 of us, and I'm one of the co-founders. So, because this talk isn't going to be funny, maybe you'll fall asleep during it. So I want to give you the take-home messages right now. Right? So the first thing is marine CDR is different than land-based CDR in that we're not directly removing carbon dioxide from the atmosphere. Right? So it's at least a two-step process. You start with doing some intervention to reduce surface ocean PCO2, the partial pressure of CO2. And then you wait for this new ocean state to equilibrate with the atmosphere, right? And it's the second step, that's the CDR. Like the first step might not do anything at all. And MRV for MCDR is challenging because of a number of things that I'll tell you about. Natural variability, carbonate chemistry is really complicated. The ocean, it turns out, it moves around. And then, as a result, direct observations of MCDR is basically impossible because of the large spatial and time scales that are involved. So this necessarily means that we need numerical models. And so, numerical models exist today, right? But a lot of them are not fit for purpose. So we need to characterize the uncertainties that are in the models in order to create sort of trustworthy MRV for MCDR. So I had said that MCDR is a two-step process, right? So the first step is you have some method to create this deficit in surface ocean partial pressure of CO2. The partial pressure is just the total pressure times the mole fraction, right? It's the amount of CO2 in the surface ocean. And one thing to explain is that, just quickly, carbonate chemistry. Dissolved inorganic carbon exists in three forms in the ocean. You have dissolved CO2, you have bicarbonate, and you have carbonate. Most of it is bicarbonate, and these things can shift around based on pH. So you have some method to reduce this PCO2. You might not be changing the amount of DIC, you're shifting between the pools. But you create this deficit either using alkalinity or you strip CO2 or DIC out of the water, like with direct ocean removal, or you have some biological methods like iron fertilization or growing macroalgae, okay? But this is not yet CDR, right? So the second step is you wait for this equilibration to happen. And I've drawn sort of two theoretical lines on here. One is the green line where the water stays at the surface, you have equilibration, you take up CO2, great. You have the red line where the water subducts. It doesn't draw down CO2, and you haven't done anything for the atmosphere, right? So it's really important to figure out, which case it is, or maybe it's something intermediate, right? So why is MRV for MCDR so hard? Well, first you have the spatial temporal scales. You do the intervention on local scales, but then the signal spreads to basin scales, really large scales where it's just impossible for you to go out on a ship and measure this. The signal to noise is terrible, right? There's a lot of dissolved inorganic carbon in the ocean, so to measure the small changes is really hard. And you need to know the counterfactual, because the ocean already takes up 10 billion tons of CO2 every year right now, right? So you need to show that what you're doing is adding to that. And then, there's the stuff that we don't know, the unknown unknowns. I hate to quote Donald Rumsfeld on this, but, there are just things that we might not know that are important. So to give you an example, so here's a numerical simulation of a pulse of alkalinity that we add in the middle of the ocean. There are two figures here. The top one is a January release, and the bottom one is a July release. And the time is shown on the upper left-hand corner. So this is years, right? We go up to 15 years. And the signal there is the PCO2 disequilibrium. And you can see that, you put some alkalinity in, you create this perturbation, but then it spreads to an entire ocean basin. And then on the right here, this figure, has two plots. That's the January and July release. And that's the uptake of CO2 over time. So even after 15 years, it's still taking up CO2. And so this kind of stuff is impossible to observe, right? So you really need, this is produced by a model. You really need a model to get at this. And one thing I should say is that the reason it takes so long is a number of things, but the equilibration between the atmosphere and the ocean is not instantaneous. It takes months, and it depends on a number of factors, and then ocean circulation further complicates that. Okay, so then if we're talking about these different scales, your intervention at the near field, and then it spreads to the local scale, and then you go to the regional to basin scale. There's no single framework to really think about this. In the near field, you can certainly make measurements, and we need to make measurements. You need to figure out, well, let's say you're doing alkalinity enhancement. How much alkalinity did you put in? How did that affect the PCO2? Those things you can certainly measure. And then you can also model some of these processes, like the near field mixing and so on. But then when you get up to the local to regional scales, then it gets a little harder to make measurements, and you basically relying on nested regional models. And then on a larger scale, you have these global models that have certain boundary conditions, or there are sort of global observations like temperature and salinity that you can use in the model to constrain the models. I mentioned unfavorable signal to noise for measurements. So I'll just give you an example here. So this is a paper that shows there are these programs in the ocean that do repeat surveys where they go and measure the same things every 10 years, right? So in this case, they're measuring dissolved inorganic carbon in the ocean. And the the ocean currently takes up, like I said before, 10 billion tons of CO2 every year. So 10 years, that's 100 billion tons, right? But basically the best ocean carbon chemists, they went out and measure dissolved inorganic carbon in the ocean, and they can't say that the ocean is taking up this amount of carbon, right? And this amount of carbon is, if Orca was designed to take up 4,000 tons of CO2 every year, that's 25 million Orca plants. But in fact, they took up 1,000, so that's 100 million Orca plants worth of CO2, and you can't see it, right? It's a lot of CO2, so the signal to noise is not great. And then you might think, well, what about sensors? Everybody thinks, oh, we can just put sensors in the ocean. We currently only have, well, let me back up a step. So the carbonate system is basically pH, PCO2, alkalinity, and DIC, dissolved inorganic carbon. If you measure 2 of them, you can calculate the other 2, okay? And you have these coefficients, which is what's plotted here. These are the different coefficients. And what's shown on this figure is that if you use pH and PCO2, it's a really bad combination to calculate alkalinity, right? And if you measure DIC and PCO2 or DIC and pH, it's much better. And you can just pick any of these, it doesn't matter. But unfortunately, we only have sensors for pH and PCO2, which means that you get this sort of huge sort of uncertainty, much bigger than your perturbations would be. So sensors are not going to be very useful for sort of the local scale. Maybe when you first do the perturbation and the signal is huge, then it's fine. And then, so here's another simulation. This is the background air CO2 fluxes. And time is here. Each one of these is a day. And it shows you the variability, right? Spatial temporal variability in air CO2 fluxes. So we're trying to detect a CDR signal on top of this kind of variability. And it's really difficult. And I talked about incomplete process understanding. So in the ocean, basically, you're looking at stuff from the gene level to the scale of ocean circulation, right? That's 15 orders of magnitude in scale, but also in time, right? We're talking about something that happens on timescales of seconds, like turbulence, to ocean circulations, which is 1,000 years. And so we're spanning, these huge sort of differences in both space and time scales. And there are certainly things in there that are important that we don't truly understand right now, or we haven't incorporated into numerical models, either because we don't know how or they're just too computationally expensive. Right? So I've sort of told you the challenges. So what's the solution? So for us at Seaworthy, this is how we think about it, right? We want to come up with something that's good enough, like something that's scientifically credible, that will return some estimate of net carbon removal, but also the associated uncertainties. It has to be done fast enough. It can't take 5 years, right? Like let's say a CDR company wants to go out and do something. We can't say, well, let us wait 5 years and we can tell you if you've done something. So it has to be, we have to be able to deploy it quickly. And it has to be cheap enough in the sense that, okay, Seaworthy's effort is something like $50 million. Companies can't spend $50 million doing MRV, right? So we have to come up with a way where what we do can be applied without spending millions of dollars. Like the MRV can't be more expensive than the carbon removal. And diverse enough in that we support the various kinds of interventions that people are thinking of. Not just ocean alkalinity enhancement or direct ocean removal, but also, if we're talking about growing macroalgae or fertilizing the ocean. And we have to give the chance to improve the system over time. So the things that I put in the top are what people are, at least in the ocean, are calling CMRV, right? Carbon MRV. But then people also worry about ecosystem, EMRV. So we want to also be able to say that, the ecosystem impacts are okay within the bounds of scientific understanding, right? As maybe a gating criteria, like, hey, if we're going to kill all the fish in the ocean, we don't do it. Right? Okay, so one potential way to do this is to create some sort of global map, right? So you can imagine, so on the left here, I show a pulse of alkalinity that we put into the ocean. And then in the middle graph, you have this plume going out over, let's say, an ocean basin. And then on the right here is the response over time, right? The change in the dissolved inorganic carbon in the ocean as a function of how much alkalinity we've put in. And we've done this for the ocean. We divided it up into these polygons. They're smaller along the coast and larger in the middle of the basin. And we basically, for each in the 4 different seasons, put an impulse in there and see over time, over 15 years, how much uptake you have, right? And so you can generate a global map like this where over, from left to right is the 4 different seasons, and from top to bottom, it's after a year, after 2 years, after 4 years, 8 years, and 15 years. And the colors are the efficiency. So in red is the most efficient, and in purple is the least efficient. So you can pick out the places where it makes sense to do this and where it doesn't make sense to do it. And in fact, we're releasing this as an interactive thing with Carbon Plan in a week. So next Wednesday, you'll be able to play with this, where you go onto the website, you can see at different times what the uptake efficiency is. You can click on any of the polygons, and you can explore how your plume of alkalinity spreads out, or your DIC uptake happens, and so on. And you can also go to any other polygon and look at a time series of how any of these things like alkalinity and DIC changes, and all the data are available. So it's something we can do. So you can think, okay, this could be an MRV system, right? But the question is, what are the uncertainties? So, I mean, there are sort of reducible uncertainties, because uncertainties that happen because we haven't sampled frequently enough or densely enough. There are empirical uncertainties where we just haven't sampled enough things, right? But then there are uncertainties due to our sort of lack of conceptual understanding of either the processes happening or we haven't put them in a model. But then there are these sort of irreducible uncertainties that happen because of some fundamental property of the system, like chaotic dynamics that we just can't deal with. So we have to know, well, what sorts of uncertainties we have, right? And conceptually, you can think of it this way, like, so on the bottom axis is time, on the y-axis is the amount of knowledge. So there are things that we can make a lot of progress on very quickly, and there are things that will take a long time. So maybe we should focus on the things that we can gain a lot of knowledge about. And so I'll just give you a quick example of sort of how we think about this. So if we're talking about an abiotic method for MCDR, we do some treatment, and then we create a PCO2 deficit. And then, as the signal makes it to large scales, you have the dispersal and the uptake, right? So in those 2 categories, you have certain sort of things that you think about. In the PCO2 drawdown case, you want to know, well, how much alkalinity did you put in, or how much DIC did you remove? And then do you have some sort of feedback, either biotic or abiotic, right? So like calcification, for instance, might feed back on your signal. And have you complied with the thresholds, either for calcification or some regulatory thing? And there are some example questions that people are currently working on, right? And some of these, maybe we can answer, some of them maybe not, and we need to figure out, which ones are which. And then, in terms of the dispersal, you want to think about, well, how do we scale from the small scale to the large scale? Because that's not, trivial. And then, do we have the mixing and circulation right? Are we using the right gas exchange parameterization? And then, we need to know the counterfactual cases. But so this is basically my last slide. So this is the way we like to think about it, right? So on the bottom is knowledge gap. So going to the right is knowledge gap. On the right side are things that we don't know. On the left side are things we do know. And then towards the top are things that are important. Towards the bottom are things that aren't important. So there are 3 quadrants that I think we can probably ignore. The things that we know well, we don't have to work on. And the things that maybe aren't as important, we don't have to work on. So it's really, the stuff that belongs up here. Whatever those things are, right? We need to figure out, well, these are the things that will help us answer these questions about uncertainty and uptake. Okay, so these are my take-home messages. Thanks.
Thank you. Yesterday, someone mentioned it was better if they welcome back up, Paul. If the panelists stand for online people, is that correct? Do you still want them to stand, or are you happy for them to sit down? If anyone online wants to comment and someone tells me sit down, it's fine. Okay. Brilliant. And thanks for a lot of questions coming in. This is clearly highly important topic, as I would think so anyway. And thanks a lot, David. That was really interesting to hear. And think that, maybe for once the land isn't going to be the most uncertain term in all the things we discussed, because it sounds like there's a lot of issues in the ocean as well. I'm going to start with a couple of questions for Paul, and starting with a question from Miles. Does net zero really mean net zero when we think about avoided emissions? But I also want to combine that with a question from Annette online.
The question was, does net zero really mean zero?
Sorry. Okay, thank you for the clarifications. And then let's see if I can find Annette's question again. Sorry, they keep jumping about. And the question from Annette was,
Non-authorized.
oh yes, what's your view on the non-authorized Article 6.4 credits,
Yeah.
i.e. with no corresponding adjustment?
So on Miles' question, unfortunately, I think Miles is probably best placed to answer it, because he's the expert on net zero and not me. But I think there is a sort of subtext, probably more nuanced point there, which is how do we deal with that question of the managed land proxy, is essentially what Miles is referring to when we're looking at land-based removals. Countries are counting everything that they manage as a removal, whether it's anthropogenically induced or otherwise. And I think, also, David, you touched on how do we baseline all this stuff? What's our baseline, and how do we detect a variation from a baseline? And actually, what we find often is that the noise in that signal is greater than what we're trying to detect is smaller than the confidence intervals of our measurement capabilities. So in fact, we're just simply looking for a nothing. We're looking into blank space or white noise because we can't detect it. And I think ultimately this is why we ended up, and I'm putting words into the mouth of the experts here, but I think it's why we ended up having a managed land proxy in the first place, because we couldn't discern what was human-induced and what wasn't. It was just it's a label of convenience which has come to stick. My archly pragmatic view on this is we should just work with it and find ways to deal with it, rather than trying to spend incredible large amounts of effort and analytical capabilities to detect what's additional and non-additional. We've seen from 20 years in carbon markets, additionality is the biggest hurdle in credibility and the credibility of those units and claims that go with them. So we want to layer in another source of additionality, not just a policy additionality, but a technical additionality as well. Then yeah, we'll be talking about this till 2100, and we might never get to net zero then, Miles, I guess. So, but on Annette's question, yeah, it's you know, again, I take a more pragmatic and simple view on this, that corresponding adjustments are something we should have in the marketplace. Of course, now we have since Sharm el-Sheikh, this idea of non-authorized Article 6.4 credits, but also it came with a proviso that they would be used for domestic crediting systems and for, nobody mentioned VCM transactions in that specific text, but that seems to be the coda that's being read into that by certain people who want to read that into that. And yeah, I don't know the answer right now, but my sense is that we should let the voluntary market do what the voluntary market wants to do, and if countries aren't willing to stand behind that and stand behind it with corresponding adjustments, then you know that's kind of where it is with the voluntary market. And the voluntary market only exists because countries aren't willing to stand behind these compliance-based systems right now. So either we get rid of the VCM and say everyone has to have compliance-based systems with corresponding adjustments, or we try to find a way to work with the VCM to have without affecting environmental integrity. And I think it's a really, really interesting topic, and I think we're still maturing our thinking a lot more around how we're going to deal with that going forward.
Great, thank you. David, you've had a lot of questions about uncertainty, including one that maybe says maybe just the ocean people are being more transparent about uncertainty than red people. But I also want, a lot related to the models and some related to whether tracers could be used in the ocean to improve things, how to trust models, and also some kind of the broad issue of whether it should be treated more like geoengineering and solar energy management with some caution. I don't know if anyone in the room, I've got Alex, Ulrika, Duncan, Pietro, Nadine and Callum all asked questions sort of around those issues. I don't know if anyone in the room, any of those are in the room and would like to articulate your question.
Yes, Axel Michael Over from University of Zurich and Perspectives Climate Research. So you have, of course, given a lot of reasoning why MRV is very difficult. So would you think that ocean CDR in general should be excluded from international carbon market? Or would you say there are categories that may be able to come in with sufficient certainty?
Yeah, I think that, so personally, I think that the abiotic methods are easier to, if I can use MRV as a verb, to MRV. And because with the, one thing that I didn't get into between the biotic methods and the abiotic methods is that with the biotic methods, you're necessarily doing something to the ecosystem, right? So already you have to worry about ecosystem harm. But then, you know, if you're growing something, the thing about the ocean is that if you're growing something, something else is gonna wanna eat it. So very little of it actually ends up in the bottom of the ocean where you want it to be sort of sequestered and not have it go back into the atmosphere. So let's focus on the abiotic methods. I think that, you know, there's a general sense that if we're able to turn CO2 into bicarbonate, then it's, you know, at least on human timescales, is permanently sequestered. And because bicarbonate just has a long residence time in the ocean, tens of thousands of years. And so I think if we can do a good job of quantifying the uncertainties so that the market, you know, if this is how it ramps up, can work, right? If buyers and sellers can trust each other, then I think the ocean certainly can play a role. And it's it has this tremendous scaling ability because, well, it's really big, but it also stores a lot of carbon. Of the active reservoirs, it stores more than any other reservoir. So yes, I think the ocean has a potential.
And related to that, I know Paul wants to come in on that, and there were also some questions about land uncertainty and how proposed methods, and maybe even a little bit of how current methods deal with uncertainty, whether methods based only on model inputs, and this kind of goes across both, should be treated in the same way as measured.
Yeah, I think it was a great question, actually. I think it came from Matthew Giddens, so thanks for that. It's one that certainly I grapple with all the time. But I think where I've kind of landed in thinking about this a bit more is that when we looked at CCS in carbon markets many years ago, and we wanted to give credit for people for mitigation actions, we wanted to make that reliant on people being able to actually observe the CO2 in the subsurface, and that's baked into the MRV and legal frameworks for this technology. You have to do certain monitoring and measurement, even in a closed system, to prove that your CO2 is staying there. I think that was a benchmark. We have to ask ourselves, are we happy with that benchmark? Is that the precautionary principle in action? I think it is. Are we willing to let backslide on the precautionary principle and have just simply modeled estimates as our basis for assuming that something has happened in the environment, be it oceanic storage, be it natural storage, be it CCS? And what are the implications of having unevenness across the piece between different CDR methods? What are the political or economic implications of doing that? How does that effectively say, well, you don't have to monitor, but you do? I think that's going to create some challenges to actually implement on a practical level. So I think striking the right balance between modeling on the one hand and observations to support your model thesis are going to be critical to actually getting CDR off the ground. I just would like to add one point, though. I mean, on Axel's question, I just wonder if we're going to create an ocean sink that can generate thousands of credits or millions of credits. Is this another kind of hot air problem what you might be looking at? But yeah, my hot air risk is big.
Maybe picking up on that is a question around, it was actually for David on interoperability across national basins. But I think it probably has similar questions about the kind of then looking at projects across borders. And I wonder if you'd both comment on the difficulty of doing these things when, ocean definitely doesn't stay in one place, but also, biomass and other resources are transported.
Yeah, well, I've had this question as well. Maybe I'll ask you this question. So we do some sort of intervention. The ocean mixes and it takes up CO2 somewhere else, but then that carbon is stored maybe in a third place. Who gets the credit?
Well, who owns the ocean? I mean, I think this is where we come into the sort of UNCLOS kind of problem of who has the rights to do what in the ocean and who can actually monetize and can we privatize those actions into cash for developers. And I think this is a much bigger question than I can answer because I'm not on the UNCLOS sort of steering committee and I'm not a lawyer or a jurist on this, but I think it's a problem.
Let's pretend it all happens within EEZs and there are only three countries, 3 EEZs.
Yeah.
The intervention, the uptake, the storage.
Yeah, I think they're going to have to negotiate it out a bit, aren't they? Because, I mean, but I think what we do have in the architecture is Article 6. Article 6, if you look at it in its purest form of the Paris Agreement, it's about cooperating. It's how do we share and make climate action happen collectively. So we have to think beyond, I've created a credit. It's not just a market. It's also more broadly about cooperation and how. So I think we can find ways. I think you need to sort of, it's kind of going to have to be a bit tricky. I think we've seen this in the CCS world where you capture in one place, store it in another place, and it leaks out in another place. And so the IPCC guidelines try to deal with that, actually. They have a transboundary section in there that explains where credit and risk should be allocated.
I'm going to push you on this. Who gets to claim it on their NDC?
Nobody, because right now, nobody's actually writing into their NDC
Right, yes.
ocean-based sinks. This is the challenge. So we have to sort of, they're exogenous to the accounting system we have today. And if we see the greenhouse gas inventories in the NDC, that relationship, which is the Paris compliance mechanism, I think, to borrow Mike Goldsworthy's words, this is the universal sort of truth that we all work around, or the universal system of accounting. Whether it's true or not is another question, but we need some kind of framework reference. But the oceans isn't in that today.
Right.
So if we put exogenous sources of credit into that, what risk does that pose for overall mitigation in global emissions, for example, or hot air basically coming into the system, where you just allow people to then continue emitting because we've modeled some ocean storage over there and chucked some stuff in the ocean, and hey, presto, we can carry on business as usual. And I think that's a question all of us are grappling with to answer, right? This is the sort of fundamental sort of challenge we face.
Yeah, and I think that if I can add a comment, is why Article 6.4 is so hard to negotiate at the moment, is because of these issues of double counting and who gets credit where, and that's already with kind of existing known CDR, and with the novel CDR. I think that's going to be what will be tackled at the IPCC meeting. And so to ask a couple of questions that are related to that. So from Yuho, the fact that there are 20 plus project level MRV methodologies for novel CDR seems confusing. Do you think we need all of them? Is there a risk of them being conflicting? Would it not be better to have a minimum number of standard methodologies? And how would you see the chances to get the IPC Good Practice Guidance update to cover novel CDRs? So I don't know if you both have any thoughts of that, or knowing or guide to what's going to be discussed at the meeting. Or I would say that there are people in the room that are going to be at that IPCC expert meeting, including Paul and Steve and Maya. So maybe that's a chance to nobble them if there's something you think you want the IPCC to raise in the scoping meeting.
Yeah, on the consistency of standards, there's far smarter people and a whole board of people on the core carbon principles doing this sort of, giving the stamp of approval, the double tick system as they call it now. So I think at the minute they're kind of the arbiter on whose standard is good or bad. Whether they're consistent, I don't know. I mean, I think consistency is a challenge. Whether they're quality doesn't always mean consistent. So I think that can be problematic, but I wouldn't want to sort of say one is better than the other. I don't think we know the answer. I think that's what the CCP is there to do. So they've got the divining stick, is Vera better than gold standard or isometric? Really difficult question to answer. But my personal view is I don't know why we need all these standards, but that's where we've ended up. So we can live with it. In terms of the IPCC meeting, I think what's going to be interesting is how much can we learn from those. I mean, like, some people have put some great effort and really good work in those standards from all different disciplines and different parts of the world with different views. So I think it's going to be really important that we actually capture that and mine that into the IPCC process and get some ideas for good and best practice. And so that's going to be really, I think it's great that people are doing that. So if there's one benefit, at least from having proliferation of standards, is lots and lots of ideas on the table to draw from.
Yeah, and just to say that I don't know about elsewhere, but the UK government call for people to self-nominate has just gone out for the IPCC CDR stuff, so I would watch out for that from your own governments if you feel you want to be involved in the process. David, I don't know if you want to comment more on that, but otherwise I've got a couple of additional questions for you. Okay, so from Duncan McLaren, given all the problems you identified, is it even conceivable to quantify the removals from a single intervention accurately enough to justify turning it into a markable carbon credit? And also related, how would multiple ocean alkalinity enhancement projects interact with each other? Would it be possible to attribute ocean uptake to a specific project or country for either project or national level accounting?
Yeah, those are good questions.
Oh, and sorry, that was from Diane, the second one.
Yeah.
Diane Hornberger.
Yeah, those are good questions. I think that with our regional models, we should be able to do that. We should be able to look at intervention scales and also look at how two different interventions would interact. But certainly with measurements, it would be hard to say who's responsible for what. But yeah, I think our goal is to get to the point where we could do that.
Great, thanks. And then I have a question from Evangelos Muchos online, which is about connecting both. What are the next steps to link land-based CDR MRV to long-term ocean sequestration at timescales over 100 years, and particularly thinking about biochar and enhanced weathering going into fresh water and then into the ocean, and also about geological storage in the ocean?
I think it's tricky because, as I say, the ocean isn't within the current MRV framework, so it's basically a source of leakage. We're basically putting carbon outside of the measuring system, and we don't know what happens to it. But David, what happens to it when you have runoff from land into the ocean?
Well, if it's bicarbonate, then you can assume that it's permanent, at least on human timescales. So I think you can just think of it as the final resting place for that carbon. So you want to get the MRV right on land to know how much you've taken up from the atmosphere.
Great, and then Nicoletta Brazola on asking if MRV is also as complicated as when you are doing the geological storage in the ocean rather than on land, like for DAC or BECCS.
Yeah, I saw this question. I think it was relating to oceanic CO2 removal with geological storage, so actually electrochemical removal. I think, look, when you've got a contained flow of CO2 and you can measure and meter it, then you always have a chance of having a better accuracy than trying to do stock change analysis. So I think, in principle, should be comparable to CCS and DACs and BECCS in terms of its monitoring accuracy.
Could you repeat that question? I think it's be very interesting.
Yes, it was. I'm sorry, I didn't read it out very. Hang on, I put it into answered, so let me just find it again. Were you in the room? Maybe you could ask again, because it's disappeared now as answered, but it's not in the answered list.
There's so many people posting that it's not working really well.
Yeah, but it was about, is it as now I'm having to paraphrase it even more. With ocean capture and geological storage, is it as complicated to deal with as geological storage on land?
Yeah, I'm not sure I understand the way that question is phrased, but
I might have said it wrong.
Maybe I'll just say something about this particular method. So some people have the idea that they want to basically strip the CO2 out of, or strip the dissolved inorganic carbon out of the ocean in order for it to take up more CO2. And in essence, what you're doing there is, taking a permanently stored source of carbon, liberating it, and having to store it somewhere else, right? And you want to make sure that wherever you're storing this carbon is just as permanent as where you took it from. Otherwise, you create a worse problem. It's like burning fossil fuels, right? You have this permanently sequestered source of carbon, and then we liberate it into the atmosphere. And so, we have to be very careful with that method that, we find just as secure of a place to store this CO2 as where it was before. But that might not be the question.
Great.
No, but I think it was a great answer.
I really apologise if I'm going to be very careful reading the next ones out. So also, David, more for you, from Charlie Morris. As mentioned, current sensors are not sensitive enough, especially for pH and PCO2 measurements, as of today. Could we consider using tracers, such as 13C for MRV?
Yeah. maybe on, I mean, it would be very expensive. Maybe on sort of the regional scale, but on global scale, you need a pretty big signal, right? Like we can see the fossil fuel signal, but that's because we put in so much carbon in the ocean. But yeah, perhaps on small scales you could do that, but it would be very expensive and it wouldn't be sensor based. Like right now, we don't have a problem making these measurements with taking the samples, and with doing C13 measurements, we would also have to take the samples. So it doesn't get around this issue of having sensors and just having autonomous measurements. Yeah.
Great, and then I'm going to finish off with a couple of biggies. There's lots more technical questions, so hopefully you'll be able to go through and have a look and answer them online. But Nick Pigeon, Nick, are you in the room? Do you want to ask yours directly?
Okay, thank you, Joe. Yeah, I'm a social scientist, Nick Pigeon of Cardiff University. There's been a lot of discussion in the conference so far of what trustworthy CDR and in particular trustworthy MRV. Bearing in mind that gaining trust is not just a question of providing the best science, what in your opinion, as the panelists, would be trustworthy MRV? What should we work to there? Thank you.
And can I add to that a question from Marco Mazzotti? Marco, are you in the room? Sorry.
You all sit together when you're asking questions.
It's easier for people online to hear with the microphone.
The question is whether, I understand the importance of having very good MRV procedures, but I wonder whether perfecting MRV, so the perfection of MRV is the enemy of the good, which is deploying these methods quick and fast and effectively.
Right, which of you wants to tackle those first?
Oh,
well, you've got your slides.
well, what I'm hearing is cake and eat it, basically. It's like for trust, we need high levels of MRV, and I think I mentioned a precautionary principle that was kind of guiding our thinking around carbon geological storage when we looked at that more than a decade ago. We wanted to observe it, see it in the ground, actually monitor it and make sure it's staying there. And I think this is the confidence that you need to build in these technologies. So whether you can we have to think about adaptation over time as well. If we build confidence through observation, perhaps we can reduce our observations over time. So, but my sense is we need, there is a trade-off, but policymakers aren't really going to be willing, in my reading of it, to throw the precautionary principle out the window to expedite these things. I mean, you've got to be a pretty brave policymaker to say, I'm going to start just counting carbon, even though I'm not able to observe whether it's really removed or not. I think nobody's willing to make that call right now. So I think that's absolutely the balance that we're looking for between those two extremes.
Yeah, and I'll just say we're not looking for perfection, right? We're looking for good enough.
Yeah.
And to the point of what's trustworthy, so we want to do something that's scientifically credible, but we're also doing it openly. So everything that we do is we put on GitHub. We make it available to everybody. They can look at our codes. They can access the data. Everything is out there for the scientific community and others to scrutinize. So I think that's how we build trust, is we don't hide anything.
Just, if I may add one more thing, just on the trust point, I think what we've seen with the criticisms of things like carbon markets today isn't about whether we can observe and monitor it successfully. It's more about would it have happened anyway. This whole additionality question is the bigger challenge, to convince the public that when private actors are making claims around things, that those claims are robust and solid. And I think that's a really tricky area. And that's highly variable across the piece as well, between, say, forestry or weathering, rock weathering, or the ocean CDR. So additionality is still a vexing topic.
Brilliant, thank you. I'd like to thank our first two speakers. And now we have our very exciting competition launch to see if we can involve some people to help sort us out some of the problems. Brilliant, well done. Oh, I hadn't realised how hard it is when all the questions are jumping about. Yeah, Paul was lucky because he was sat next to me seeing most of the ones.
Hello and good morning, everybody. Welcome to the final 13 minutes of this morning session, which was really great. And I think we continue on the same topic, but on a slightly different angle, because in the next moments we will launch a new student competition in the area of MRV called the Smart CDR competition. My name is Juho Lipponen. I'm a coordinator of the Mission Innovation CDR mission. Here on stage with several colleagues, all linked and affiliated to the mission, and we'll do this launch together. And organizers, thanks so much for allowing us to take 15 minutes of the valuable plenary time to do this. Very, very, very appreciated. And also thanks a lot for putting our project on the front page of the app, so you can already see what we're talking about on the app. And there will be this QR code will be shown on many of the slides, so you can also flash it as we go along. Who in the room has heard about mission innovation? Great, quite a few. We're not totally unknown. Mission innovation is a group of today 24 countries, really East and West and global North and global South all represented. And these countries have come together to accelerate innovation and catalyze clean energy solutions for all. The MI has 7 work streams, appropriately called missions, and CDR mission is one of them, and that's the group that is hosting this launch with you this morning. It's a first of a kind government platform to accelerate RD&D for CDR technologies. We collaborate through various collaborative initiatives. We enable learning by doing, demonstration projects, foundational data availability, we improve that, advanced collaborative R&D. And we have a number of countries. We're co-led by 3 countries, and that's Canada, Saudi Arabia, and the US. And we have a bunch of very active members, also the UK, to mention one of them. Our membership is through government, but we collaborate with all types of organizations that are interested and relevant in the area of CDR. So if you're interested in finding out more, please do come talk to us after this. Before we go to the competition, just a brief mention. A number of our colleagues have worked a lot in getting the CDR competition up and running, and they were not able to be there today. I'm talking about Faisal Kouroni from from Saudi Arabia, Ministry of Energy, Matt Antis from US Department of Energy, and Kay and Steph from Natural Resources Canada. So a big shout out to them for the enormous work they've done. Great. We move to what this competition is all about, and I'll let Roger Ains from the US Department of Energy take us through the competition.
Thank you, Juho. I'm Roger Ains. I'm the Senior Advisor for Carbon Dioxide Removal to the US Department of Energy, which is one of the co-leads of this effort. And it's a great pleasure to announce a student competition here. You just heard how challenging and important MRV is. It's brand new. It's a great thing for students to be engaged in. And we're going to put some mentorship and some cash and some attention behind this for those of you who want to participate, and hopefully share this QR code for your friends and colleagues who also want to participate. We want us to get the best possible applications. It's an international activity. It is not highly structured. We want new ideas in in MRV, hopefully with interdisciplinary and perhaps even international teams. We're trying to focus on new ideas, but remember, this is a focus on people. This is a way to bring more people into the field. And the idea of having attention is going to be highlighted by Lars when he speaks next, that among the 3 teams will win cash, and 6 teams will get to go to the Climate Summit and present their work there and get a lot of attention. And so we're hoping that's going to attract a lot of attention and a lot of good ideas from all of you, and I will turn it over to Lars now to tell you about what's going to be won.
Okay, thank you, Roger. My name is Lars Ingolf Eide. I assist Gassnova, which is a Norwegian state CCS enterprise, and I assist them in their work in the Mission Innovation CDR. And Norway, together with Japan, is leading the bikers track. Gassnova is pleased to host the final of the CDR Smart competition in connection with the biannual Climate Summit that takes place in Larvik, Norway, next February 25 to 26. And maybe I should add that Climate is a Norwegian RD&D program for CCS. And we expect, next slide, you, please. We expect to receive 400 delegates from around the world to this conference, and this is the first time since 2006 or something that the summit will host a global CDR program, and that will take place on the first day, February 26th next year. And the conference will feature a presentation by governments, industries, academia, and there will be panel discussions, all on topics related to CDR. And the 6 finalist student teams will be invited to present their work and compete for the 3 top prizes. And the 3 winners will be announced and awarded during a dinner later in that evening. In addition, the program will include a site visit the next morning to a CCS plant, a facility as a cement plant in nearby. And this is open both to students and to delegates. And the summit itself will take place February 26, 27, and it's open to everyone. There's no fee for participating. The results from the climate, it will include status on global CCS, status on the Norwegian CCS project Longship, results from several climate projects, announcement of the climate award, and several side events. And there will also be possibility after the summit to some site visits. And Gassnova is pleased to partner with the CDR mission on the program, and we welcome you all to Larvik next year. Over to you, Jo.
Thank you, Lars. Thank you. So that's what awaits the 6 finalists and the winners in Norway. Now, the competition would not be possible without the sponsors, or maybe it would, but it would be considerably less appealing because there would be no prizes. But we have wonderful sponsors who've agreed to sponsor our program. Capsark and Kaust are our platinum sponsors, contributing $25,000 each. We have Kaxt as a gold sponsor, contributing $15,000, and Oxford Institute of Energy Studies and Carbon Engineering, both each contributing 10 grand. So thank you very much for this generous contribution. 3 of these groups are with us today, and since you've been generous with us with all the cash contributions, we will be generous and allocate something like 90 seconds to each of you to say who you are and why you are supporting this competition. Starting from you, Nasser, please.
Thanks to you. Good morning. Capsark, King Abdullah Petroleum Studies and Research Center in Riyadh is basically an advisory think tank focusing on global policy, economics, and sustainability. Our mission is to advance and help decarbonize the energy sector in Saudi Arabia and beyond. through evidence-based research and also providing advice to the ecosystem entities within the kingdom. CDR, over the past few years, has become very important and obviously growing, of growing importance in Saudi Arabia. And this is why CAPSARC launched a multi-year project on CDRs, which covers techno-economics, life cycle analysis, many aspects, but MRV is the overarching theme here. And as we heard from our speakers earlier, the challenges facing MRV, I mean, we can see that obviously CDRs having different maturity levels and readiness levels in terms of deployment, for CDR. This is why CAPSARC think that it is important to advance MRVs for different CDRs. And so we are, very excited and happy to be sponsoring this competition. I'm looking forward to receiving many interesting submissions and the initiation of interesting projects. Thank you.
Over to Hassan.
Hi, everyone. Hassan Muslimani, Head of Carbon Management Research at the Oxford Institute for Energy Studies, or better known as OIS. For those that are not familiar with us, we're just based down the street from this building. OIS is a research center focused on all aspects of energy transition. We do work on electrification, hydrogen renewables, decarbonization of oil and gas, and carbon management, which is where I sit. And as far as carbon management goes, we evaluate business cases for different CDR solutions, the challenges to scaling them up. We work very closely with industry partners, including carbon engineering, but we also look at the deployment of CCS in hard-to-abate sectors. And obviously, one of the biggest challenges to upscaling is MRV. That's why we're all here. We also do have a team dedicated to methane emission MRV, if that's something you're interested in. And so that's why we're very interested and excited to be sponsoring this competition, to see what ideas the students are going to come up with, what new methodologies. Hopefully some of the prospective applicants are in this room or joining us online. On top of that, I already mentioned to Hugo that we are, as OIS, offering the opportunity on top of the cash prize for the winning teams to collaborate with our researchers to further develop their ideas, potentially publish their results with us. So I hope this will provide for an additional incentive if one is needed on top of cash. Yeah, we're very excited about this. And over to you, Hugo.
Great. And finally, Ryan from Carbon Engineering.
Hi, everyone. I'm Ryan Edwards, lead policy with Oxy, here representing Carbon Engineering. Oxy is the parent company of Carbon Engineering, and together we're currently building the world's largest, what will be the world's largest DAC facility down in Texas using Carbon Engineering's technology. And I'll use this as a plug opportunity that tomorrow at the business case, I'm going to have a table with the latest construction footage of Stratos, so please come check it out. So we recognize that foundational to the business case for Stratos and for any CDR project is the trust of our customers that they're getting the carbon removal they paid for. And obviously MRV is critical for that. We've recognized that for some time. Oxy was the first company to receive a approved MRV plan from the United States Environmental Protection Agency for geological CO2 storage way back in 2015 now. And so, yeah, so therefore we're recognize that how critical this is going to be for developing a CDR industry. So we're pleased to be able to support the competition for two key reasons, which we've already heard. Number one, to help support the MRV development that's going to help be the foundation of that industry. And secondly, to help get smart people involved in MRV and CDR generally. So thank you.
Wonderful. Thanks, Ryan. And thank you to the three sponsors present. And finally, we turn the mic over to Isabella, Team UK, to talk about the key dates going forward.
Thank you, Juho. Hello, everyone. I'm Isabella Butnar, based at University College London and representing the UK team and MICDR. I'm here to take you through the key dates for this application to the prizes. First of all, this is the official launch, so please do scan the QR code and read more about the conditions and guidelines for how to apply. We are expecting your submissions by the 9th of September. when there will be a decision on the best projects to proceed to phase 2. So by the end of September, you will know if you were selected to go forward, and then by December, you will be preparing a 5,000-word proposal with help from the Oxford team and the MICDR team. And then in December, the semi-finalists, 6 teams of students will be announced to go to Norway to climate. And 3 of them then, so all 6 will get to present their ideas, excitingly, and then 3 of them will be getting the big prizes, which were announced before. Thank you very much. Back to you.
Great, thanks Isabella. So student competition, prizes are mentoring, travel stipends, cash, possibility to partner with organizations to develop your ideas further, and of course fame at the end of the day. And saving the planet. Thank you, Miles. Saving the planet. Indeed, yeah. Under the QR code there, you'll be launched to a website on HeroX, and you'll find all the information necessary there. So. Please, if you are a student and want to apply, do apply. If you know of students who might want to apply, talk about this. We will be posting this on our LinkedIn feed and elsewhere, so please feel free to amplify and let's talk about this opportunity in the coming weeks so that as many people as possible around the world will know about it. Very good. Well, thanks everyone for the fun moment together. I think we'll take questions afterwards, and we'll end the from our side now. We're very scared if we go under a similar kind of grilling as Paul and David. So we won't take questions here. Thanks everybody.